Hello students, in this video we will quickly revise all the concepts from 10th chapter, that is circles. What is secant and tangent? Here we will take three cases. In the first case there is a circle and there is a line PQ. Okay. In this case the PQ line is not touching the circle nor intersecting the circle. In this case it is not touching the circle nor intersecting the circle. Okay. And we will take another case. Okay, this is a circle and this line PQ. Okay, this line PQ is touching the circle at one point. This line PQ is touching the circle at one point, this point, and this point is known as point of contact. This is called point of contact. If the line is touching the circle at one point, this line is called tangent. Okay, this line PQ is called a tangent. And we will see the third case. We will take a circle and we will take a line PQ. Okay, this line PQ is intersecting the circle at 2 points. Okay, this line PQ is intersecting the circle at 2 points. Okay, then this line is called a secant. This line is called a secant. Okay. Now we will see the theorem 10.1. The tangent at any point of a circle is perpendicular to the radius through the point of contact. That means we will take a circle, okay, and a line is touching the circle. And this line PQ is a tangent and the point of contact. We will assume this point of contact as A. Okay, and we will take the center O and this OA is radius, right? OA is radius, and this theorem 10.1 is telling that the tangent is perpendicular to the radius. Okay, where it is perpendicular? It is perpendicular at the point of contact, right? Okay, this is theorem 10.1. Here we will answer these few questions. First one, a tangent to a circle intersects it in how many points? This is a circle and this is a tangent. Tangent means it will touch the circle at one point. This is called a point of contact and it will intersect in how many points? At one point, right? The answer is 1 here. The next one, a line intersecting a circle in 2 points. This is a circle and this is a line. This intersects the circle at 2 points. This is P and this is Q. If it intersects at 2 points, this is called a secant. This is called a secant. Next one, a circle can have how many parallel tangents at the most? Okay, this is a circle. Okay, tangent means it will just touch the circle, right? How many parallel tangents it can have? 2. It can have 2 parallel tangents at most. That means maximum it can have 2 parallel tangents. Next one, the common point of a tangent to a circle, and the circle is called what? Okay. See, this is the common point of the tangent to the circle and the circle. Okay. See, this is the point of contact. It is point of contact. That means at this point, the tangent and the circle are meeting. Okay. Next one. Here we will see few questions. Is it possible to draw a tangent from the point that is lying inside the circle? See, here is a circle. If we take a point inside the circle, is it possible to draw a tangent? Okay, is it possible like this, okay? This will not form a tangent, this will not form a tangent, this will be chord. So the answer is no here. Okay, second one, if a point is lying on the circle, see, we will take a circle. If a point, this point, it is lying on the circle, then how many tangents can be drawn from that point? Okay, how many tangents can be drawn from this point? 1 tangent, right? Can I draw like this or like this? Can I draw like this? No. Here 1 tangent can be possible when a point is lying on the circle, right? And the third one, if a point is lying outside the circle, how many tangents can be drawn from that point? So this is a circle and we will take this point P. Tangent means it should touch the circle, right? So this is just touching the circle, right? So this point P that is lying outside the circle. So from this point P, two tangents can be drawn. Here the answer is 2. Next one, theorem 10.2 says that the length of tangents drawn from an external point to a circle are equal. See, this is a circle and this is an external point P. And the tangents that are drawn from this point to the circle, these both are equal. Okay, this is the theorem 10.2. It is telling that the tangents that are drawn from an external point to the circle are equal, right? Next one. These are the examples that are given in NCERT. We will solve these. Prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. See, there are two circles, okay, and the center is same for these two circles. These are called concentric circles. That means one circle is lying inside another circle and these both circles have the same center, okay. And the chord of the larger circle which touches the smaller circle, okay. Here the chord of the larger circle will touch the smaller circle. So this is the chord AB. This AB is the chord for the bigger circle and AB is the tangent for the smaller circle, right? And we will take the center as O and we will take the point of contact as D. Okay, we will join OD. OD is the radius of the smaller circle. We will take as R1. R1 is radius of smaller circle. And we will take R2 as radius of bigger circle. Okay, and we will join OA. OA is the radius of the bigger circle. It is R2. And OD is the radius of the smaller circle R1. And what should we prove? The chord of the larger circle, this AB, is bisected at the point of contact. That means this AB is bisected at D. That means AD is equal to DB. We have to prove this. We have to prove this. Now we will join OB here. Okay, we will join OB and OB is also radius. It is the radius of the bigger circle. It is R2. And we have seen the theorem 10.1. What is it? The tangent. This AB is the tangent to the smaller circle. So the tangent is perpendicular to the radius. That means angle ODB is equal to 90 degrees. Okay. And this angle ODA is also 90 degrees. And angle ODA is equal to 90 degrees. And OB is equal to radius of bigger circle and OA is radius of bigger circle. It is R2. And OD is equal to R1 and OD is equal to R1. So here we will compare both the triangles. What are the triangles? Triangle ODB and triangle ODA. Okay, here we are comparing this both the triangles. ODB, this is 90 degrees and ODA, this is 90 degrees. And OB is equal to R2, OA is equal to R2 and OD is common, it is R1. So by using RHS property, these both triangles are congruent. Okay, if this both the triangles are congruent, then the corresponding sides and corresponding angles are equal. So this implies AD is equal to DB. Okay, because these both are the corresponding sides. And hence we have proved that chord of the larger circle is bisected at the point of contact. Next one. Second example, two tangents TP and TQ are drawn to a circle with center O. Okay, this is the circle, center is O and this is the external point T. And TP and TQ are the tangents. This is TP and this is TQ. Okay. Prove that angle PTQ is equal to 2 angle OPQ. We have to prove angle PTQ is equal to 2 angle OPQ. This one. We will join OQ. Here OP and OQ, these both are radius. Okay. And the tangent is perpendicular to the radius according to theorem 10.1. So So angle OPT is equal to angle OQT is equal to 90 degrees. And OPTQ, this forms a quadrilateral, right? This forms a quadrilateral, and we will add all the angles in the quadrilateral. It is angle POQ plus OPT, it is 90 degrees, plus angle OQT, it is 90 degrees, plus angle PTQ is equal to 360 degrees. So angle POQ plus angle PTQ is equal to 360 degrees minus 180. It is 180 degrees. And we will take this triangle OPQ. We will take triangle OPQ. Here OP is equal to OQ. OP is equal to OQ because they both are radius. So this forms an isosceles triangle. So angle OPQ is equal to angle OQP because the angles opposite to equal sides are equal. So we will assume these angles as A. Okay, and in this triangle OPQ, sum of angles in a triangle is 180 degrees. So OPQ, it is A plus PQO, it is A plus angle POQ, it is 180 degrees. So here angle POQ is equal to 180 degrees minus 2A. We will substitute this equation in this first one. Okay, we will get angle POQ. Angle POQ is what? 180 minus 2A. 180 degrees minus 2A plus angle PTQ is equal to 180 degrees. Okay, here 180 and 180 will be cancelled. We'll get angle PTQ is equal to 2A. Here A is what? It is angle OPQ. It is 2 into angle OPQ. Okay, this is what asked. We have proved it. Next one, third example. PQ is a chord of length 8 centimeters. This PQ is equal to 8 centimeters of a circle of radius 5 centimeters. This OP is equal to 5 centimeters. The tangents at P and Q intersect at a point T. Okay, see this tangents, PT is a tangent and TQ is a tangent. These both tangents intersect at T. Find the length TP. We have to find this length TP. See, radius is given and the tangent is there. So first thing you have to do is mark it perpendicular. Okay. See, tangent is always perpendicular to radius. So angle TPO, this is equal to 90 degrees. Okay. And OT, it is the distance between center and the external point. This OT is the bisector of PQ. OT is the bisector. OT is the bisector of PQ. So PR is equal to RQ. So PR is equal to RQ. So PR will be what? PR is equal to half of PQ. It is 4 centimeters. PR will be 4 centimeters. See, OT bisects PQ and it bisects at 90 degrees also. Okay. So angle PRO, this is also 90 degrees. Okay. If you see the triangle PRO, by using the Pythagoras theorem, you can find RO side. Okay, how? It is PO square, hypotenuse square is equal to side square, PR square plus RO square. So here PO square is 5 square is equal to PR square is 4 square plus OR square. Here you will get OR is equal to 3 centimeters. Here OR is equal to 3 centimeters and we have to find the length TP. So we will compare the triangles PTO, triangle PTO and triangle PRO. Okay, see, we will take triangle PTO. Okay, see, angle P is 90 degrees in this triangle. Okay, angle P is 90 degrees in triangle PTO. So what is 90 degrees in this? So what is 90 degrees in this smaller triangle PRO? R is 90 degrees. So first we will take R. And in this both the triangles, angle O is common. Angle O is common. So O will be at same place. So O will be at same place. The rest is angle T and angle P. Okay, this is angle T and this is angle P. These two triangles are similar. because here it is 90 degrees and angle O is same. So we will take the ratio of the corresponding sides. PO divided by OR is equal to PT divided by RP. So here PO is what? 5 divided by OR is 3 is equal to PT is what? X divided by RP. RP is 4. So here X is equal to 20 divided by 3. This is the answer. Next question. Now we will solve few MCQs. These are from NCERT and these can be asked in your exam. So first one, from a point Q, the length of the tangent to a circle is 24 centimeters and the distance of Q from the center is 25 centimeters. The radius of the circle is what? See, this is a circle and from a point Q, this is Q, the length of the tangent to a circle. Okay, this is the tangent. The length is 24 centimeters and the distance of Q from the center. This is the center O and the distance is 25 centimeters. The radius of the circle is what? See, the tangent is perpendicular to the radius and we will assume the point of contact as P. See, OP is perpendicular to PQ. So angle OPQ is 90 degrees. This forms a right angle triangle. So by using Pythagoras theorem, we can find OP value. We can find radius. So how do we do? Here hypotenuse square is equal to side square. It is OP square plus PQ square is 24 square. So 25 square minus 24 square. It is OP square. Now this is in the form of A square minus B square. It is A plus B into A minus B. 24 plus 25 plus 24 into 25 minus 24 is equal to OP square. This is 49 into 1. It is 49. So what is radius here? Root of 49. It is 7. So the radius of the circle is 7. Second one, if TP and TQ are the two tangents to a circle with center O. This is the circle. This is point T. TP. This is P and this is Q. TP and TQ, these are two tangents to a circle with center O. So that angle POQ, this angle POQ is 110 degrees. So what is angle PTQ? What is this angle? Okay. See, this OP is radius. OP is radius and PT is tangent. So tangent is perpendicular to radius. Similarly, TQ is tangent and OQ is radius. TQ is perpendicular to OQ. So this forms a quadrilateral. OPTQ forms a quadrilateral and in the quadrilateral sum of angles is 360 degrees. So here angle POQ, it is 110 degrees plus angle 90 degrees. It is OPT plus angle PTQ plus angle TQO plus 90 degrees is equal to 360 degrees. Here angle PTQ is equal to 360 degrees minus 90 plus 90, 180. 180 plus 110, it is 290. Okay. So the answer is 70 degrees. Angle PTQ is 70 degrees. Next question. If tangents PA and PB from a point P to a circle with center O. See, this is a circle and this is the point outside the circle. PA, this is A and this is B. PA and PB are the tangents. These are inclined to each other at angle of 80 degrees. Okay, this is 80 degrees. Find angle POA. This is O, this is the center. We have to find angle POA, this angle. So we will join OB here. OB and OA, these both are radius here. And AP and PB, these both are tangents. So tangents are perpendicular to radius and this forms a quadrilateral. OAPB forms a quadrilateral and sum of angles is equal to 360 degrees. So angle OAP, it is 90 degrees plus angle APB, it is 80 degrees plus angle PBO, it is 90 degrees plus angle AOB, this is 360 degrees. Okay. So here angle AOB is equal to 360 degrees minus 90 plus 90, 180 plus 80, it is 260. Okay. So angle AOB is 100 degrees. Okay. See, this OP is the bisector. OP is the angle bisector of angle AOB. So angle AOP will be half of angle AOB. So this is half of 100. It is 50 degrees. First option. That's all in this video. We have covered all the concepts. If you want me to solve the questions that are in the NCERT, then please let me know in the comment box. I will definitely try to make a video. Thanks for watching.